Hi everyone. In our galaxy of over 100 billion stars, signs of other civilizations are conspicuously and mysteriously absent. Given humanity's rapid evolution towards a technological singularity, why haven't we found AI probes and other traces of advanced alien civilizations that have also reached superintelligence? Is extraterrestrial life cosmically rare, or is there a more elusive reason for this radio silence? Keep watching to learn more. This video has 3 parts. Is life out there? Explanations for silence, and implications of humanity. Part 1. Is life out there? This question was most famously posed by physicist Enrico Fermi, who apparently over lunch to a couple other physicists said, "Where is everybody?" meaning alien civilizations. This question has come to be known as the Fermi paradox, because at first glance it seems like there should be tons and tons of life out there, but we've seen no evidence of that. There are between 100 and 400 billion stars in our galaxy, even though the galaxy is only 100,000 light years across. And there are so many potential instances where life could have arisen. After the Fermi paradox came the Drake equation, which tries to formulate the likely number of alien civilizations that exist, or rather, the number of alien civilizations that are actively communicating. Unfortunately, the Drake equation is highly dependent on variables that we don't have good bounds for. The variables are just all multiplied together to indicate the probability of them all happening at once. And those variables are the rate of star formation, the proportion of those that have planets, the proportion of those that support life, the proportion that actually develop life, the proportion that develop intelligent life, the proportion that develop technology, and finally, how long each civilization lasts for. Depending on which values you pick for those 7 variables, you can derive that we are likely alone in the observable universe, or you can also derive, if you use values like those that Drake originally used, that there are somewhere between 1,000 and 100 million planets with civilizations on them currently in the Milky Way galaxy. So you'll see the Drake equation talked about a lot, but in reality, it's not that helpful to us yet. Variables like the proportion of planets that develop life or the proportion of planets that develop intelligent life can't be estimated very well until we have at least one other instance of life in the universe. There's another similar formula, however, with terms that are easier for us to calculate now with the information that we have about the universe. And it's called the Astrobiological Copernican principle. In the paper where this principle was first introduced, they provided strong and weak limits on the number of civilizations in our galaxy right now. There's supposed to be lower bounds. So the paper thinks that there must be at least this many civilizations, although there could be more. The numbers they came up with were at least 36 civilizations under the strong limits, which are the most restrictive limits, to 475 or even 928 civilizations alive right now in our galaxy under weak limits. The difference between those last 2 numbers is dependent on how much metal is required in a planet's crust to enable the formation of life. Again, even under the strictest limits, this paper concludes that there are at least 36 civilizations alive and well in our galaxy right now and able to communicate with the outside world. However, given the density of stars in our galaxy, those civilizations are at least 1,000 to 3,000 light years away. So round-trip communication might not be possible, especially if you assume the worst case where perhaps civilizations are only communicating for 100 years total, which is about how long humans have been communicating for in terms of sending radio waves into space. If civilizations die out quickly or whatever, then you don't really have a hope of having a round-trip communication time, which could be 2,000 or 6,000 years. Also, the expected distance to the nearest civilization for us is 17,000 light years. So 1,000 light years away is actually a good case. What this means is that it's entirely plausible that there's lots of life out there that we haven't found yet, but may in the future, even within our own galaxy. Let's talk about AI for a moment. It's highly likely that if we do encounter an alien civilization, that it would be AI and not biological life, especially if they're coming to visit us or something. Biological life needs a particular environment to survive, while AI is just a computer which can be safely sent over interstellar distances much more readily. Interstellar space is a really hostile environment. In fact, our own spacecraft that we put into space right now have special radiation-hardened processors that are not going to get some bits flipped if they're hit by cosmic radiation. It's quite difficult to produce radiation-hardened processors, and they're generally about 10 years behind state-of-the-art in terms of processor design. Anyway, more importantly, other civilizations might be millions or even billions of years older than our own. That's plenty of time for the original biological aliens to evolve into cybernetic beings or to create completely artificial superintelligence, and maybe even evolve beyond that. We don't really know. Rather than describing these alien civilizations as AI, it would be more accurate to describe them as postbiological. That's the term that astrobiology literature uses to describe civilizations that have merged with or are actually forms of AI. But the term AI sort of implies an artificial origin, which is not necessarily the case, right? It could have been a gradual evolution from biological beings into their current state. It's also different from the term posthuman, which means humans that have alterations such that they might not be considered plain vanilla humans anymore, but which doesn't have anything to do with AI. Part 2. Explanations for silence. There are many possible explanations for why we haven't run into aliens yet, many possible resolutions to the Fermi paradox. One blog I was reading lists 14 different possibilities, and I also saw an academic paper that described 50. That's a lot, so we'll just describe a few in this section. First, the great filter. Maybe there just aren't any aliens at all. That's why we don't see any. The idea behind this explanation is that one of the steps of evolution could be a so-called filter, something that's very unlikely and something that's difficult to get past. In essence, this would filter out a lot of potential civilizations at earlier stages of biological evolution. So in this model, there could be tons of planets with life out there, but they're just stuck at an earlier phase of evolution, and they haven't yet reached the point of intelligent species with technology that's open to communicating with the rest of the universe. There are many potential hard steps in our evolutionary past, including self-replicating cells, multicellular organisms, sexual reproduction, complex and large brains, technological development, etc. Also related to this is perhaps the civilizations, when they do evolve all the way to the point of being communicative technological civilizations, perhaps they don't last very long. I think we've seen in humanity's past that some technological developments can be pretty unstable and destabilizing. And of course, humans are always arguing with each other, and there's always conflicts over resources and other things. So as we develop more and more sophisticated weaponry, the chance of us destroying ourselves actually goes up over time. So actually, the last of the hard steps is essentially stick around long enough to actually communicate with alien civilizations. The second explanation is the dark forest theory. This theory says maybe civilizations keep quiet and don't communicate because it's dangerous to do so. It's called the dark forest theory because you can envision the galaxy as being a really dark forest where you don't know if there are predators out to get you. For example, it's pretty easy to destroy a planet from afar by taking any small object, accelerating it to relativistic speeds, and turning it into a missile. If you've watched The Expanse, you know all about that. In other words, a first strike attack is actually very plausible at the interstellar level. So a civilization that is unwisely perhaps announcing its presence by sending out communications might find itself being bombarded with no real way to defend against that, and not even knowing who is sending the bombardment. In interspecies game theory, maybe it makes sense to keep to yourself as much as possible. Although even all this doesn't explain why we don't see megastructures like Dyson spheres or other evidence of galactic engineering. Surely the oldest and most accomplished civilizations wouldn't be as afraid. Hard to say. The other issue is that when you're dealing with time delays at interstellar distances, you can easily get out of date, technologically speaking, when compared to an opponent if you're actually engaged in an interstellar conflict. This might put even more pressure on civilizations to perform a first strike when they can just send some rocks around and get rid of their opponents, instead of getting involved in a long, drawn-out war that becomes very difficult because anytime you send out attackers, they're up against stronger defenders because they've had time while your attack fleet was in transit to increase their technology level. This is actually the main central plot point around the book The Forever War, where starships get sent to enemy star systems and spend years or decades or even centuries in transit, and they might end up missing their opponents or their allies by long periods of time, and certainly they're going to experience a difference in technological level if they spent a long time in transit. The soldiers in the book are then able to go back home at some point where hundreds of years have passed and they don't recognize anything at all. I have previously recommended this book, but I guess that's the recommendation for this video as well, The Forever War. A third explanation might be the way in which we're actually looking for extraterrestrial life with SETI. SETI stands for Search for Extraterrestrial Intelligence, and they've been in charge of this whole endeavor since the beginning. However, they're currently focused on searching for radio waves, electromagnetic radiation, under the assumption that any technological civilization is going to start emitting those, perhaps unintentionally, or if someone wanted to send us a message, they would probably do so by sending EM radiation. We ourselves have only been emitting electromagnetic signals for about the last 120 years, which is not a long period of time, but of course, we're galactic babies. Any potential civilizations more than 120 light years from us would not have received anything yet, even if they knew where to look. And actually, this is a place where AI, specifically deep learning, can make a huge difference. signals. Previous SETI work has all been based around signals processing, but there was a recent work that used deep learning to train a model on these are terrestrial signals, these are unusual signals, and to try to spot the difference. They actually took a big data set of 150 terabytes of observational data that had previously been combed through and nothing had been found, and they reanalyzed it with the deep learning method. That system actually came up with 8 different signals of interest that are potentially of extraterrestrial origin. Now, this type of thing has happened a lot in the past where people find something and then it turns out it's actually of terrestrial origin or it has some natural explanation. So far, these 8 signals haven't been proven one way or the other. They do look very promising, as in very unlike most signals that would originate from planet Earth. So maybe our AI will help us find the other AI that exists out there in space. But the point is that SETI is really focused on this one type of so-called technosignature. They're assuming that aliens are going to produce electromagnetic radiation. However, we might actually end up only emitting electromagnetic radiation for a few hundred years. Once we have better technologies, we might stop actually broadcasting radio signals all over the place, especially if any of us believe in the dark forest theory. There are tons of other technosignatures that we could be looking for that would indicate some technological civilizations out there. One crazy one, for example, is we could actually look for Hawking radiation coming out of black holes. Because black holes are incredibly dense, they're a great way to experiment with quantum phenomena. And there's one theory that sufficiently advanced civilizations would probably use black holes as supercomputers, quantum supercomputers. Specifically, they would probably create microscopic black holes because those emit the most Hawking radiation that can be leveraged for quantum computations. So the process of running these quantum computers that are black holes would emit lots of Hawking radiation, and also the process of forming these black holes would do the same. So one potential technosignature is, hey, it looks like there are a million tiny black holes in this region of space. Maybe that's a quantum computer. So anyway, one reason that SETI may not have found any extraterrestrial intelligence may be because we're only looking at a particular type of signal, which may only be valid for a short time period during a civilization's evolution. Part 3. Implications of humanity. The fact that we as humans exist right here, right now, is actually something of a puzzle. We are incredibly early during the history of the universe, so early that it's statistically improbable, unless, for example, earlier civilizations will eventually prevent future civilizations from arising. However, we're also not so early that we should be the absolute first, which is what it looks like when we look into the sky, which again is also improbable, unless earlier civilizations all destroyed themselves or never talk or something. So from the mere fact that we exist and that we can't see anything, we can actually infer a fair amount about what civilizations might look like. First, let's talk about this theory called Grabby Aliens. As I mentioned, humanity evolved incredibly early during the history of the universe. Right now, the universe is 13 billion years old, but stars will continue burning for the next 100 trillion years. In other words, 99.9% of the time during which civilizations could arise, at least if they arise in orbit around stars, has yet to happen. In other words, we are in the 0.1% earliest possible time. And again, the Copernican principle, which I alluded to earlier, says that we shouldn't expect to find ourselves in a special place in the universe. Copernicus being the scientist, of course, that disproved that the Earth was the center of the universe. So why are we so close to the beginning? Maybe because civilizations don't arise after a certain point, which would probably happen because other civilizations have already colonized every possible planet. That's why this is called the Grabby Aliens model. It hypothesizes that some alien civilizations are grabby. They're just going to go out and colonize all the possible planetary real estate and then sit on those planets for a long period of time so that there's no chance for any native life forms from those planets to evolve into intelligent species. The Grabby Aliens paper models everything about this scenario. How likely civilizations are to become grabby, approximately 1 in 1,000, as well as their speed of expansion, approximately 1/3 the speed of light, relying only on the constraint that we are typical observers. Everything else slots into place if you assume that everything is going to get colonized eventually. Basically, it doesn't make statistical sense that our civilization rank is 0.1%, so you can play with all the variables to put us at a more normal point in the history of the universe by just making it impossible beyond a certain point for life to arise. Also, according to that model, around half of space is already colonized. We just can't see it because they're not in our galaxy yet. In fact, we should expect to see the first grabby alien civilization in the next 500 100 million years or so. And who knows, it might even be us. It's a pretty fascinating paper, and if you want to learn more about it, I highly suggest watching the video by PBS Spacetime, which I'll leave a link to in the description below. Since it's statistically improbable that we're the first civilization ever, we can infer something else about how civilizations behave, specifically that they might grow much more slowly than we would expect. And yes, I know this is the exact opposite of Grabby Aliens, but hear me out. Our own population as humans used to grow exponentially, as per the biological imperative. Evolution programmed us to reproduce as much as possible. But now, in many advanced societies, we've stopped having children. Most developed countries are actually having children lower than the rate of replacement, so their populations are either shrinking or they're only growing because of immigration. Our focus now is on the exponential growth of the economy, and more of the economy is going to be digital. So our focus might be turning inwards away from physical replication and physical resource gathering, which would be a good thing because growing exponentially is not sustainable, not in the long run. For example, if you had self-replicating von Neumann probes that were programmed to just reproduce themselves as much as possible, they could consume the entire galaxy in 500,000 to 10 million years. That's all the matter in the entire galaxy converted into probes. Considering that a civilization might accidentally program some von Neumann probes with these instructions, you can see how uncontrolled exponential growth can be dangerous. In fact, if a civilization lasts a fairly long time and has highly expansionist tendencies, then it would also only take it about 500,000 years to colonize the entire galaxy. Again, that hasn't happened yet, so if there are any other civilizations out there, it's quite probable that they are growing at slower rates. It's quite probable that they are not exponentially trying to use all their resources and all their habitat the way that humans or life on Earth would have done to survive in Earth's biosphere. Another way to put it, I guess, is there might be alien civilizations out there, but none of them have been Grabby aliens yet. There's also some reason to believe that superintelligent AI would not have an incentive to spread, at least not spread exponentially. Swedish mathematician Daniel Wallström put together a paper which is a draft paper. It hasn't been published yet, but it describes qualitatively why super AIs may not be incentivized to spread. The logic there is that there are diminishing logarithmic returns from resources, whether material resources or computational resources, while as the society gets more complicated, there are increased incentives to be cooperative. Amongst humans, for example, cooperativeness has increased for the last 61 years, at least according to US data, as the wealth and technology level of the country increased. Though I suppose that wars may be reversing that trend a little bit right now. The argument is that old societies and super intelligent AIs would also be incentivized to be highly cooperative. They would need a strong reason to expand extensively out into the galaxy. Put another way, they'd need a very good reason to expand beyond the couple of Dyson spheres that they had constructed for themselves around a few star systems, where they can happily do whatever they would like. If you're unaware, a Dyson sphere is a shell that's built around a star to capture all of its light, to capture all of the energy that a star puts out, to be able to use it for its own purposes. The Dyson sphere can also be used to provide a lot of living space on the inside. It's a theoretical megastructure that we could potentially envision a civilization creating. Finally, some of my thoughts. We'll probably only use electromagnetic waves to communicate for a few hundred years at most, and we may turn inwards because of our focus on the economy and digital environment. Our focus might be on creating a Dyson sphere for increased living space and for powering tons and tons of computers. Maybe eventually we might make a Matryoshka brain, which is a computer fully powered by a Dyson sphere. Basically, you have something that captures all of the energy and then a layer of computers around that, and so on, using all the waste heat from the inner layers. It's named after Russian dolls, the Matryoshka dolls. I think also that superintelligences can likely observe us without being observed in turn, and there's probably no incentive for them to broach initial contact with us, at least during this phase of our development. Probably a lot of civilizations, if they exist, are small and keep to themselves, one reason potentially being the vast distances of interstellar space. If you've colonized a bunch of stars across different areas of space, but those entities can't communicate with each other at faster than the speed of light, then you've effectively created a bunch of different countries with tons of lag and skew time between communications, and a really good chance of developing adversarial relations. So while there may still be some interstellar empires approaching us, if Grabby Aliens is to be believed, it seems likely to me that they would need to rely on faster than light communication. So, are there post-biological civilizations out there that we haven't run into yet? I don't know, but it's completely possible. Finally, in conclusion, we talked about the Fermi paradox that says, where is everybody? Even though, quite plausibly, other alien civilizations could have arisen. arisen by now. We also discussed the Drake equation and the astrobiological Copernican principle, which use a lot of variables to try to predict how many civilizations might be out there that are willing to engage in communications. We went through a few explanations for the silence that we see in the heavens, including the great filter theory, which says maybe there just aren't any aliens because they got stuck at some earlier phase of biological evolution and they got filtered out, so to speak, filtered out of the running. Also, the dark forest theory, which says in interspecies game theory, it's best to be silent. And finally, the way that SETI goes about searching for extraterrestrial intelligence is somewhat limited, and maybe we're just not searching for the right patterns. In terms of implications that we can deduce from our own existence and the fact that we haven't seen anyone else yet. First, it seems like we are incredibly early during the history of the universe, which leads to the theory of Grabby Aliens that might be going through the universe at approximately 1/3 the speed of light and colonizing every possible planet. And second, we're not so early that we should be the absolute first civilization ever in our galaxy, so maybe a lot of civilizations undergo much slower growth patterns. Once a superintelligence arises, there might be a game theoretic reason that it wants to keep to a few stars, and the further we get from our biological imperatives, perhaps the less inclined we are to consume the entire galaxy. Do you think aliens are out there? Do you think we will see evidence of them anytime soon? Do you think humanity will be a grabby alien civilization, or will we take only the resources that we need at an interstellar scale, like potentially the elder races among us? Let me know in the comments, and don't forget that we have a Discord channel now, so check that out in the links as well. If you liked this video, check out this previous one I made about how humans might reach beyond biological bodies. It's a future history of our own ascension to a post-biological civilization. All right, that's all I have for today. Thank you very much for watching. Bye.